Mr. Client here from Maths. Today we're going to look at the SQA Higher Maths paper for 2023. Let's get started. SQA Higher Maths 2023 paper 1 question 1. Y equals x to the 5 thirds minus 10 over x to the 4. So we need to get it ready to differentiate first to find the y by the x. So y equals x to the 5 thirds minus 10 x to the minus 4. And then I can do the y by the x. Take a power to the front. Take away 1, so that is 2 thirds. And then take the power to the front in times, but minus times a minus is a plus, so plus 40 x to the minus 5. You probably don't need to go any further, but just for the sake of completeness, that would give you 5 thirds, x to the 2 thirds, plus 40 over x to the 5, and we're done there. SQA Higher Maths 2023 Paper 1 Question 2. P and Q are points minus 2, 6 and 10, 0. Find the equation of a perpendicular bisector. So if I've got a line, let's say it was here, minus 2, 6 and 10, 0. Perpendicular means at right angles, bisector means in half. So I'm looking for a line that looks like this, I suppose, where that's at right angles and it cuts it in half. So I'm going to need the midpoint and the gradient of perpendicular. So let's start off with gradient. The gradient of P to Q is y2 minus y1, so that's 0 minus 6, over x2 minus x1, 10 minus 2, that's negative 6 over 12, which is negative a half. So that means that the gradient of our perpendicular straight away equals 2, and we need to write since m1 times m2 equals minus 1. So we've got our gradient is 2, now we need our point, so the midpoint. So the mid of PQ, we add the x's, so we've got 10 minus 2 divided by 2, and the y's, 6 plus 0 divided by 2. That gives us 8 over 2 and 6 over 2, which is equal to 4 and 3. So we've now got our point and we've now got our gradient, so we can use y minus b equals mx minus a. So y minus b equals mx minus a, where that's our a and b, and that's our m. So we've got y minus 3 is 2x minus 4. Y minus 3, 2x minus 8. So y is 2x minus 8 add 3 is minus 5. And there we are. SQA Higher Maths 2023 Paper 1 Question 3. Solve log 5x plus minus log 5(3) equals 2. So rules of logs, if it's a minus with the same base, you can divide these together. So in one step, we get log base 5 of x over 3 equals 2. And then you need to get rid of the log. So remember, it's base to the power of this equals this. So in other words, 5 squared equals x over 3. Or, to write it nicely, x over 3 equals 25, 5 squared. X divided by 3 equals 25, so that means that x must be 3 times 25, so x equals 75, and we're done there. SQA Higher Maths 2023 Paper 1 Question 4. Diagram shows two right angled triangles, P and Q is marked. Find cos P, cos Q, and then cos P plus Q. So cos P first of all, so we've got this triangle up here, opposite, adjacent, hypotenuse, so Pythagoras, 5 squared minus 4 squared is 3 squared, so that is a 3 here. We might as well do the same on the other side now to get the hypotenuse, so we've got 6 squared plus 3 squared, 36 plus 9 is 45, so the other hypotenuse is the square root of 45, which is root 9 times root 5, which is 3 root 5. So I can note that as 3 root 5, or you can leave it as root 45 to the now and then simplify it later. So our cos P then is nice and simple. Opposite adjacent over hypotenuse, 3/5. And our cos Q, opposite adjacent over hypotenuse, 3 over 3 root 5, which now simplifies to 1 over root 5. So if you wrote 3 over root 45, you would have to simplify root 45 at that point. Now it says determine the value cos P plus Q. So you go to the start of your exam paper and you read off what cos P plus Q is. Cos P plus Q is cos P cos Q minus sin P sin Q. So I'm going to need sin P and sin Q. So let's do cos P cos Q first. We have got 3 over 5 times 1 over root 5. And then at the side, we can just do a little box here. Let's work out our sin P. So back up to our triangle. Sin P is 4/5, opposite over hypotenuse. And sin Q, back to our triangle, opposite over hypotenuse, 6 over 3 root 5, which we can simplify straight away by dividing by 2 to get, which we can simplify straight away by dividing by 3 to get 2 over root 5. So then we've got minus sin P 4/5 times sin Q 2 over root 5. So that equals 3 over 5 root 5 minus 8 over 5 root 5. 3 minus 8 is minus 5, so we get minus 5 over 5 root 5. And we can simplify that by taking 5's out. Divided by 5, you get minus 1 over root 5. Do not be tempted to divide these because that's under a root and that isn't. SQA Higher Maths 2023, Paper 1, Question 5. The equation 2x squared plus 3p minus 2x plus p has equal roots. So if it's got equal roots, b squared minus 4ac equals 0. So our a is just the number in front of x squared, which is 2x. Our b is 3p minus 2, the number in front of x. And our c is whatever's left on the end, which is p. So we can do b squared minus 4ac, 3p minus 2 squared minus 4 times 2 times p equals 0. So we need to expand the double bracket. The quick way with a square bracket is square the first. 3p is 9p squared. Twice them times together. So 2 3s are 6. Times 2 is 12. So you get minus 12p. And then square the last. 2 2s are 4. So that's our first bracket. Then minus 4 times 2 is 8 times p is minus 8p equals 0. So we get 9p squared minus 20p plus 4 equals 0. Now we need to see if that can factorise. That's a bit of a nasty one. So I'll briefly go over factorising. We do 9 times 4 is 36. I'm looking for factors of 36 that add together to make minus 20 or 20, I suppose. So 1 and 36 is not going to work. 2 and 18 will work because I can now do minus 2 minus 18 equals minus 20. And minus 2 times minus 18 is 36. So I can split this middle term up into 9p squared minus 18p minus 2p plus 4 equals 0. So then to factorise it, I'll just factorise like this dotted line. So taking 9p out as a common factor, I'll get p minus 2. And on the other side, I'm still needing p minus 2 because I want the same factor. So times by minus 2 to get minus 2p. And just check minus 2 times minus 2 is plus 4. So then my factorisation is complete. It's what's outside the brackets, 9p minus 2, and the inside p minus 2 equals 0. So 9p minus 2 equals 0, or p minus 2 equals 0. Solving the left-hand side one, 9p equals 2, so p is 2/9. That's our first solution, or p equals 2. And that's our second solution, and we're done there. SQA Higher Maths 2023, Paper 1, Question 6. Integrate 2x to the power of 5 minus 6 root x dx for x greater than or equal to 0. So integration without limits means there's going to be a plus c, but I need to get it ready to integrate. Root x becomes x to the half. So I'm going to integrate integrate 2x to the 5 minus 6x to the half dx. So integrate, add 1 to the power, divide by the new power. So x to the 5 becomes x to the 6, and I've got 2/6 minus 6x, add 1 to a half, you get 3/2. So I have to divide by 3/2, and I've still got plus c. So dealing with the first one is easy. 2/6 is a third, so we've got a third x to the 6. Divided by a fraction, same as times and by its reciprocal. So times by it and then turn it upside down. So I've got minus 6 times 2/3 x to the 3/2 plus c. So that gives me 1/3 of x to the 6. 6 2s are 12. 12 divided by 3 is 4. So minus 4 x to the 3/2 plus c for our final answer. SQA Higher Maths 2023, Paper 1, Question 7. Part A, evaluate log 2, 5 plus log 2, 1 over 40. So part A, rules the logs again. Same base with a plus means I can times these two together. So that becomes log 2, 5 times 1 over 40. So that is log base 2 of 5/40, which is log base 2 of 1/8, because you can divide by 5. Imagine it as 2 to the power of something as 1/8. Well, 2 to the power of 3 is 8, so 2 to the power minus 3 is 1/8, because it's 1 over 2 to the power of 3. So that means that 2 to the power minus 3 equals 1/8. So this means that the answer is minus 3. Part B. Given A is a member of the real numbers and that log 8a is negative, state the possible values of A. So we're saying that log base 8 of A is negative. So less than 0. We don't need to write the is. So log base 8 of A is less than 0. Let's just think about it logically for a minute. Let's imagine that we did 8 to the power 0, we get 1. If we take a negative number then, we get 8 to the power of, let's say, negative 2. That's the same as 1 over 8 squared, which is a fraction. And if I take any negative number, 8 to the power of a massive negative number would be a fraction. So it's always going to be either as big as 1 or as small as almost 0. So that means that 0 is less than A is less than 1. We can see this on a graph, I suppose. If I draw a basic log graph, there is 1 there, and below the x-axis is when it's negative. So less than 1 it's negative, but only up to 0, it never touches 0. So it's between 0 and 1. So that's another way you could have thought of it. SQA Higher Maths 2023, Paper 1, Question 8. A function is defined as a set of real numbers by x cubed plus 3x squared minus 9x plus 5. Find the coordinates of the stationary points of f and determine their nature. Stationary points means derivative equal to 0. So we can write stationary points occur when f dash x equals 0. So f dash x is equal to 3x squared. 2 times 3 is 6, so 6x minus 9, and then the 5 disappears. So we're saying 3x squared plus 6x minus 9 equals 0. 3 is a common factor, so we get x squared plus 2x minus 3 equals 0. It's keeping our common factor, a standard one to factorise. We've got x and x. It has to be 3 and 1. And plus 3 minus 1 is 2. So that implies x minus 1 is 0, so x equals 1. Or x plus 3 is 0, so x equals minus 3. So we've now got our x part of the coordinate. We might as well try and find our y part. So when x equals 1, y equals, substitute into the original, x cubed plus 3x squared minus 9x plus 5. 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So that gives me y equals 1 plus 3 minus 9 plus 5. Y equals 1 plus 3 is 4. 4 plus 5 is 9. Minus 9 is 0. So our first coordinate is 1, 0. When x equals minus 3, we can do the same thing. So y would be minus 3 cubed plus 3 times minus 3 squared minus 9 times minus 3 plus 5. So keeping your wits about you, because it is an on calculator, 3 cubed is 27, so you get minus 27. 3 squared is 9 times 3 is plus 27. 9 times 3 is 27, but it's plus because of a minus times a minus. And then you've got plus 5. Minus 27 plus 27 is obviously 0. So then you've got 27 plus 5, 32. So your second stationary point is minus 332. So there's my two stationary points. Now we need to determine our nature by using a nature table. So a nature table is like this. We're going to go along to our first point. This is our x, so minus 3. And then along. And then we're going to examine the other stationary point. So I'm going to go along to 1. And then along. I always keep it separate in case there's a point of a discontinuous point. I don't want to lose wax. There isn't in this case, but just in case. So then we're just looking at our derivative, f dash x. So picking numbers, we know that at minus 3 it's 0 and at 1 it is 0. So we need a number less than minus 3. Now, it's always best just to do a derivative to examine it already factorised. So just pick a number less than minus 3. Let's just pick minus 4. Minus 4 minus 1 is negative. Minus 4 plus 3 is negative. A negative times a negative is a positive. So I know it's positive before minus 3. So I can just write that. And after minus 3 but before 1, let's just put 0 in. That gives you negative. And that gives you positive. Negative times a positive is a negative. So we know that it's negative here. And therefore, after minus 3 but before 1, it's still negative. After 1 though, just pick 2. 2 minus 1 is positive. 2 plus 3 is positive. Positive times a positive is a positive. So we get a positive again. So our shape, it goes up, along and down. So max, down, along and up. So it's a min. So we need to state that. So minus 332 is a maximum turning point. And 1, 0 was it? 1, 0 is a minimum turning point. And we're done there. SQA Higher Maths 2023 Paper 1 Question 9. The diagram shows the graph of function f of x is log base 3x. X is greater than 0 of course. The inverse function does exist. In the diagram in your answer book, draw the graph of the inverse function minus 1. Well, let's examine the inverse function first. The inverse function of a log is an exponential. And essentially the easiest way to draw it, imagine a dotted line here, y equals x. The coordinates just switch places, okay? So here is my normal y equals x. So 1, 0 becomes 0, 1. And 3, 1 becomes 1, 3. And it just gives you an exponential curve. And that would be 1, 3. So that's the inverse function of x. So now I just need to take away 1, which means just to move it down by 1. So 1 is going to go to 0. And 1, 3 is going to go to 1, 2. So I can just draw it now. There's 0. It's obviously going to drop below because that's where your asymptote is, essentially. So it's going to go along, up through 0 and start climbing. And we just put that point on that we noted, which was 1, 3. So it now becomes still 1, but 2. And we're done there. SQA Higher Maths 2023 Paper 1 Question 10. Show that x plus 5 is a factor of this. And it's a 4th power one. And then hence or otherwise solve it equal to 0. So usually we do cubics, but 4th powers can come up. So you're going to show it's a factor, you're going to end up with a cubic, and you're going to have to then start with a cubic by just guess and check to find another factor. So let's start off showing it's a factor. Easiest way is using synthetic division. So x plus 5 is a factor, so I'm subbing in minus 5. So it's 1x to the 4 plus 3x to the cubed minus 7x squared plus 9x minus 30. So we drop the 1 down, times them together to get minus 5. Minus 5 plus 3 is minus 2. Times it by minus 5 again, you get 10. 10 minus 7 is 3. Times by minus 5 again to get minus 15. Minus 15 plus 9 is minus 6. Times it by minus 5 again to get 30. 30 minus 30 is 0. Two options for your statement. You could write f of minus 5 equals 0, and therefore x plus 5 is a factor. Or the alternative is just writing since the remainder is 0, x plus 5 is a factor. Either of the options are fine, but you need to write a statement. Hence, otherwise solve the equation. So part B, we now know that it becomes x plus 5. Then you've got x cubed minus 2x squared plus 3x minus 6 equals 0. We're going to have to check numbers here to find another factor. So the easiest way is direct substitution. So if I try 1, we're going to get 1 cubed minus 2 times 1 squared plus 3 times 1 minus 6. 1 cubed is 1. Minus 2 is minus 1. Minus 1 plus 3 is 2 minus 6 is minus 4. So it's not that one. Try minus 1. You get minus 1 cubed minus 2 times minus 1 squared plus 3 times minus 1 minus 6. Minus 1 cubed is minus 1. Minus 2 is minus 3. Minus 3 is minus 6. Minus 6 is minus 12. So it's not that one. So then you would try 2, and you're just doing it systematically. Once you get bigger, you can go back to synthetic division. I'll stick with this for 2, because it's quite simple. 2 cubed minus 2 times 2 squared plus 3 times 2 minus 6. That's 8. 2 2s are 4 times 2 is 8. Plus 6 minus 6, that's 0. Therefore, we've got another factor of x minus 2. So we're going to have to synthetic division it anyway, but we now know 2 goes in. So synthetic division just on the x cubed minus 3x squared plus 3x minus 6. 1x cubed minus 2x squared plus 3x minus 6. And we're subbing it in 2. Now you could have just done that to the start and done it for 1, minus 1, 2 and so on. We've got 1, 2 1s are 2, minus 2 is 0, 0 again, plus 3, 3 2s are 6, 0. So because since f of 2 equals 0, x minus 2 is a factor. Or since the remainder is 0. At this stage, you don't have to show that it's a factor, so you don't really have to need the statement, but just to be on the safe side. So we've got x plus 3 still, x plus 5 still, sorry, and then x minus 2. So that implies our original function, which is x4 plus 3x cubed minus 7x squared plus 9x minus 30 equals 0 becomes x plus 5, x minus 2, and then we've got, this has become a quadratic, x squared plus 0x plus 3, and that equals 0. Now we need to solve it, so each factor becomes equal to 0, so that implies that x plus 5 equals 0, or x minus 2 equals 0, or we could say x plus 3 equals 0. The first one gives us x equals minus 5, second x equals 2, and this one, no solutions because If you take it over to the other side, you get x squared equals minus 3, and you can't square a negative number. SQA Higher Maths 2023, paper 1, question 11. Part A, integrate between pi over 2 and pi, 5 sin x minus 3 cos x. And then part B is draw a picture. So part A, the integral between pi over 2 and pi of 5 sin x minus 3 cos x dx. I'll stick to radians for this because radians is integration only works in radians, it doesn't work in degrees anyway. So check in front of the exam paper and it will tell you that sine integrates to minus cos. So we've got minus 5 cos x, and then cos integrates to sine, so minus 3 sin x, and our limits are between pi over 2 and pi, so we're subbing our limits. So we get minus 5 cos pi minus 3 sin pi. Take away minus 5 cos pi over 2 minus 3 sin pi over 2. Now, although I'm doing it in radians, I like to think in degrees. So I know that pi is 180. The cos of 180 is just minus 1. So that's minus 5 times minus 1. And the sine of 180 is 0. So that's minus 0. And then take away, pi over 2 is 90. The cos of 90 is 0. So that is 0 for the first term. And the sine of 90 is 1. So that is minus 3 times 1. So that gives me minus 5 minus 1 times minus 1 is just 5 for the first bracket. Minus 3 on the second bracket, but times another minus outside, so plus 3, which gives me a grand total of 8 square units, because we've not got any units. So you'll probably not need this, but just to be on the safe side, but 8 is our answer. On the diagram in your answer book, shade the area represented by the integral in A. So the integral is between pi over 2 and pi. There's pi, so we can mark pi. And pi over 2, 90. So there's pi over 2. So it's a bit between these. So we can just draw some vertical lines and shade in this bit and shade in this bit. It's the integral between them, so it's the area between the curves at that point. It's just asking if you understand if that means that. Just check your areas. You've got 5 sin x on the top, minus 3 cos x, which is exactly what we were integrating. So it's the integral between these two curves, between these 2 points. So we're done there. SQA Higher Maths 2023, paper 1, question 12. Express this in the form ax plus b squared plus c. Complete with square, in other words. So to complete with square, and imagine a dotted line in here, and I take out the common factor. So I've got minus 2 x squared, then it'll be plus 6x. So it's minus 2 times 6 is minus 12, but I've still got plus 7 hanging on the end. So I take my minus 2, big brackets. I'm going to complete with square on this. So I half the term, x plus 3 all squared, and I immediately take away 3 squared. But I've still got plus 7 hanging out on the end. So I've got minus 2, x plus 3 squared, minus 9, plus 7. Expanding that, then I've got minus 2, x plus 3 all squared. Minus 2 times minus 9 is plus 18, but I've still got plus 7. So I've got minus 2, x plus 3 all squared. 18 plus 7 is 25, so plus 25. And we're done there. SQA Higher Maths 2023, paper 1, question 13. 2 functions f and g are defined as f of x is 2 sin x for between 0 and pi over 2, and g of x is 2x for between 0 and pi over 4. Evaluate f of g of pi over 6, and then find an expression for f of g over x. So we might as well do the first one directly instead of going f of g of x first, but you could have done that first and then subbed it in. So for part 1, I want f of g of pi over 6. Well, g of pi over 6 is simply 2 times pi over 6, because g of x is 2x. That is pi over 3. So f of g of pi over 6 is just simply f of pi over 3. F is 2 sin x, so it's 2 times the sine of pi over 3. So we sine of pi over 3 is an exact value. If you don't know it, pi over 3 is 60 degrees. So I've got 60 degrees here. I've got, I think, equilateral triangle. So it goes 2, but it's been cut in half 1, and that's root 3. So the sine of pi over 3, opposite over hypotenuse, is root 3 over 2. So that's 2 times root 3 over 2, which is just simply root 3 as our final answer. Part 2, determine expressions for f of g of x. So f of g of x is equal to f of, well, g of x is 2x. So that is 2 sine 2x. 2 sine 2x. And we're done there. Part B, given that f of p is a third, determine the exact value of sine p. So f of p, part B1, f of p is just going to substitute p in, 2 sine p. But it's told us in the question that f of p equals 1/3, and therefore sine p is equal to 1/3 divided by 2, which is 1/6. Part 2, hence determine the exact value of f of g of p. So B part 2, f of g of p. Well, f of g of x is 2 sine 2x, so f of g of p is 2 sine, just change it to a p. So 2 sine 2p, well, sine 2p is 2 sine p cos p from the start of the exam paper. So it's 2 times 2 sine p cos p, which is 4 times sine p cos p. Now, I know sine p is 1/6. So if sine p is 1/6, if I draw a little right angle triangle and call that p, opposite's 1, hypotenuse is 6. So I can do Pythagoras. 6 squared minus 1 squared, 36 minus 1 is 35. So that side is the square root of 35. So this gives us 4 times the sine of p, which is 1/6, times the cos of p, which is going to be adjacent of hypotenuse, which is root 35 over 6. You may be wondering, is root 35 a simplified third? Well, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it. So no, it's already simplified. So when we just times the top, 4 root 35, times the bottom, 36. Simplify the 4 and 36 to get root 35, 4 nines are 36. Doesn't look simplified, but it actually is. There's nothing else you can do with that, so we're done there. This has been Mr. Klein for Klein Maths. Today we went through the whole of the higher maths paper for 2023 paper 1. Hopefully you found that useful. Take care, stay safe, and goodbye.